Welcome back everyone. In this topic we're going to discuss window functions. Now sometimes you'll see these being discussed as analytical functions, but essentially what window functions allow are for very complex queries. So for example, if you were looking to find the two checks paid for each claim which are the most value, or you wanted to get a running declaration of the number of days between one check and the next for each payee, then those kind of complex queries, you could solve those using complex SQL statements, but window functions makes it a lot easier to resolve those kind of questions. So let's take a look at how a window function works. In this particular example, you've got a number of orders here, and you see three different suppliers, and you see the payment made to each supplier. Now the final column is where window functions comes in. The first thing we do is we determine a window. We find a partition that we're creating on the data that we have available to us. So what we've done, we've partitioned by supplier here. So we're saying for each supplier, which is our window, for each supplier we're looking at the maximum payment made within that window. So let's step through it slowly so it's clear. Supplier number one we've got is Vickers. There's only one payment made to it, so the maximum payment that's been made to Vickers is £300. The second supplier we have is Potter Bay. Potter Bay has three payments of 550, 1050 and 700. Now, if you look at that entire window of data, the largest amount paid is 1050. And what window functions allow you to do is declare that amount next to every single row in that window. So in this case, 1050 is the largest payment, and that's the max payment value that you see in the column there, against every single record for Potter Bay. Similarly, when we look at Jennings, we see there are four payments there, two for 650 each, one for 480, and a final one for 900. So 900 is the largest check payment that's been made to that particular supplier. And for that partition or window, we declare that max payment next to every single record. And that allows us to do some very interesting analysis on the data. As we're looking at every single record, we're able to compare it to the largest amount that's ever been made for that particular partition or window of data. So we define our partition. We're saying that that's the supplier. So for every single supplier, we're applying a function, which is max payment, over that partition. So think of it like this. We're looking at the maximum payment value over that entire partition of each supplier that we have in our data. And we're going to call it the max payment. And if you break it down like that, it's much easier to understand. So let's look at that syntax on the right hand side. We have a aggregate function there, the max payment. So we're taking the maximum payment value, but we're not taking it across every single record in that table. We're taking it over the partition that we're defining. Our partition, or our window, in this case is the supplier. So every single supplier becomes a partition. So in this case, we've got three partitions there visible: Vickers, Potter Bay, and Jennings. Let's concentrate on the Jennings one. So we're looking for the max payment over the partition of supplier. So in this case, the supplier is Jennings. And we're going to call that max payment value max underscore payment, right? So for Jennings, the maximum payment is 900. And because we're only looking at each partition at a time, we're going to declare that 900 next to each record in that partition. So break it down in that way and it's much easier to understand. Define your partition, define the function that you want to apply to that particular partition, and declare the column value or the column name for that particular result. So the partition in this case is supplier, The function that we're applying is the max aggregate function, and the column we're going to put that value into is called max payment. It's important to know that because we're using the over clause, we are defining partitions. Any function that we use without that over clause is not a window function. It just becomes the standard aggregate function that we've done before when we looked at group by. And that's the basic concept behind window functions. So let's take a look at some examples now. So here we are inside pgadmin. Let's start with a standard aggregate function in a group by clause that we've done in the past, right? Where we're basically selecting the maximum check amount against each check payee from the transaction table. We see against every single check payee, we see the actual highest check value that's been written against each of those payees. Now, there is so much other information in that table, and there are so many other records against each check payee, but we don't see any of that. All we see is the check payee ID and the maximum check written against that particular payee. What we're not able to see is all of the other transactions alongside that maximum check value. If you think back to the slide that we went through when I was explaining window functions to you, you'll see that one of the advantages of window functions is that it allows you to bring back all of the records, but at the same time maintain this ability to do aggregation against each of those records. So let's start that process off. Let's first of all see what else we have in that table. So we see, for example, there, check payee 37, we see two separate transactions there. Now, those are all hidden from us when we do something like a group by clause and an aggregate function against the check amount, because what it's doing is it's saying for each of those check payees, bring me back one value, which is the maximum check that's been written against that particular payee. It won't allow you to bring back every single transaction record, and that's where window functions comes in. What we're going to do is bring back each of these records for each of the check payees, and alongside each of those payees, give us the maximum check that's been written against that particular payee. Now, the payee here is going to be our window or our partition. So we're going to partition by check payee. So let's build this query up. I'll just do a cut and paste it for speed. This is the maximum check amount that we want displayed against every single record. But in order to be able to do this, we need to use the over clause. Didn't define T. So what's SQL done here? What SQL has done is basically found the maximum check value on the entire table, because we haven't specified any partition within the over clause. We've basically said, yes, we want to use a window function, but our window is the entire table. So for every single transaction in that table, it's added this column of max check. It's found the maximum check amount across the entire table and applied it in the max check column. So our partition is effectively the entire table here. But what we want to do is limit that partition to the check payee so that we get the maximum check value only for the group of transactions which link to a specific check payee. Become clear when we put this in. So if we do partition by check payee, and we run this now. Now let's look down. So if we go down this table now, we see check payee 61. There's 3 records there, 3 check amounts, £450 and 2 for 2050. So the largest amongst those 3 is 2050. And what SQL has done is put that value against every single record. So our window or our partition now, because it's limited to check payee, SQL will run that max check amount against each of those partitions and put that value at the end of each of the records in that particular partition. Whereas before, it was taking the entire table, because we hadn't specified a partition, found that the largest check was 8,820 and put it against every single transaction, irrespective of check payee, because we hadn't actually defined that partition. So just once again, when we define a partition, SQL applies the function against the records only in that partition and gives us the value at the end of each record. So you can see how powerful window functions are now, because it allows us to both list every transaction but also apply a function or an aggregation against the records within a particular partition that we define. And in this case, the partition that we've defined is based upon check payee value. Now I'm going to introduce you now to the use of row number within window functions. And this is a really useful facility within the use of window functions in SQL, because it allows you to put a unique value against each of the rows that are coming out for each partition. And you'll see the value of that in a moment. Let's write the code first. We'll leave out the partition definition to start off with. So let's run that. Oops. To define T. Right, so what have we got here? So what we're saying is that we haven't defined our partition, so whatever we do now is going to be applicable across the entire table. But what we do want to do is get the row number back for each value in the partition. So what SQL will do will assign a unique value to define the row number that we're getting for that entire partition. Now in this case, our partition is the entire table. So like before, we applied a aggregation or a function, we were doing the max check payee value, yeah? So the max check amount we were doing. In this case, what we're doing, we're saying to SQL, give us the row number across the entire partition and call it Rownum. And what this is doing now is giving us a row number value against every single record in that table, because the partition is the entire table. However, once we start partitioning, then that row number becomes applicable to that partition only. So if we start putting in here partition, let's capitalize this, partition by check payee, and we run that, we now see that Rownum only being unique to each partition. So, for example, check payee 17 only has one record, and the row number 1 is applicable to that one record. Check payee 22, there are 2 records in there, and for each record in that partition, Rownum will be different. So you've got records 1 and 2 within that partition. Same for 26, there are 2 records there. There's record 1 and 2 within that partition. So now we know that 63 has got several transactions against it. And you see for that particular partition, we've got Rownum 1 all the way down to 40. because we have 40 different transactions within that particular partition based upon the check payee. Now, where this comes into its element is when we start doing the addition of an order by. So if we were to do something like order by the check amount, this is within the partition. So we've defined the partition as check payee, and within that particular partition, we're going to order the records that are being displayed by the check amount. So if we do this, now when we look at, say let's go to 63 here, this particular partition, you see that the actual check amounts are now being ordered in the actual value, so they're going up in value. Now, the great thing about this is now it allows us to determine what are the first n number of smallest check values. Or if we were to do this in reverse, if we were to do descending check amount and ran that and went down to 63, we could now determine the top 3 check values which have been paid to check payee 63, because what we're doing, we're ordering by the check amount in reverse order. So we've said descending here, and it said, okay, 8,820, 8,820 and 3,920. They're the top 3 checks that have been written to payee 63. So now you're seeing the value of using window functions, because it allows us to determine things that would have been very complicated to determine using an alternative method within SQL. We can now say for any particular check payee, what are the top 5 check values that we've sent out to that particular payee. So 66, there is 4,000, 2,700, 2,355, 2,355 again, and 2,200. Those are the top 5 check amounts that we've sent out to this particular payee. And that is the value of using window functions in SQL. It allows us to do that kind of querying of data that would otherwise take us very complicated SQL to determine. And we're doing that in one statement. So now what could we do with that query? We could then say, let's just pick out the top 3 checks against each of those check payees. We're not interested in finding any of the ones where there's more than the top 3 checks. So obviously for this particular payee, we have 40 different transactions there, but we're only interested in the top 3. So we can answer that query that we were looking at in our slides earlier. We can do something like select check payee and check date and check amount from this subquery, and we're going to have to give it an alias because it's a subquery, so we say, call it checks, where, Rownum is less than or equal to 3. Okay, and if we ran that, now what we're doing, we're only bringing back the top 3 checks that were written against each of those payees. So for 63, you see those are the top 3 checks on those particular dates. We actually have 2 checks the same for the top 2 checks which are written for this particular payee. Now that's not incorrect, because they're actually separate checks on 2 separate days there. But they're the top 3 values we have when we do our ordering within that partition. Let's just run that subquery again. And I want to just explain something to you further. So within these partitions that we've created, you see that row number is applying a unique value against each row in that particular partition. So row number is an excellent way of picking out the top value within a particular partition, whether it's based upon date or amount. So if we want to do, for example, order by check date, and we were to run that, this allows us to determine the very latest check that was paid to each particular payee within that partition. Okay, so we know that the number one record in that partition is for 63 was 27th of April 2022. So that's an excellent way of determining the latest payment that was made against a particular payee. Now there are other functions that we can apply, and we're going to have a look at rank and dense rank next.